So here we go. Here's a little bit more gas law practice for you. Let's start with a gas stoichiometry. So take a moment, read this problem, and see what you would do first. All right. So hopefully you were thinking, oh, we need to write the equation first. So HCl, how much HCl would be generated if NaCl reacts with sulfuric acid. Keep in mind this is at STP, standard temperature and pressure. Our standard temperature is 0 degrees Celsius. Standard pressure is 1 atmosphere, exactly what we're under right now. And at STP, 22.4 liters of a gas is 1 mole of a gas. All right, so this would be a great time to pause the video. Take a look at that 10.2 grams of NaCl. See if you can figure out what volume of HCl would be produced. All right, how did you do? Hopefully what you did was what I have right down here. You started with the given, converted your grams of NaCl to moles of NaCl using the molar mass of NaCl, then looked at your balanced equation. 2 moles of NaCl equals 2 moles of HCl. And then you use that standard 22.4 liters of a gas at STP. And so hopefully you came up with, rounded to 3 significant figures, 3.91. Let's take a look at another gas law problem. Here you go. Great time to pause the video and come back and see how you did. All right. So hopefully you are looking at all of these pieces of information, noticing that you have 1 volume and 2 temperatures. So again, volume and temperature, that's going to be Charles's Law. Charlie Brown is a TV show. And so hopefully you just use that equation. Right there you've converted I converted my milliliters to liters because that's what I always do. And hopefully you came up with your volume 0.3087 liters. And I'm going to have to round that to 2 significant figures. So 0.31 liters or 31 milliliters. All right, here's another one. All right, great time to pause the video and see how you did. Hopefully, as always, you've figured out you're trying to do moles. And so all you need to use is 22.4 liters of a gas is a mole. So when you take that volume that's given and convert it to moles using that 22.4, hopefully you came up with something like that, and then rounded to 3 significant figures. I use scientific notation to do that right here. All right. Here's another one. So taking a look at this, hopefully you're again taking a look at what's given. I'm noticing 2 temperatures and a volume. So Charles's Law again. So great time to pause the video and see how you can do. Hopefully you've got something sort of like this. And to solve for V2, hopefully you came up with 3.3. Technically, I would need to round that 1 more significant figure, so it'd be 3 milliliters. Or excuse me, 3 liters. All right, here's another one. So hopefully you're taking a look. I see a volume, a pressure, another volume, pressure and volume. PV, that would be boys play video games, Boyle's Law. So again, a great time to pause the video and see how you do. Hopefully you came up with something like this. No conversions needed there. You can keep that pressure in kilopascals. Here's another one. I guess you won't need to pause the video to see this one, but you will need to take a look and get your pressures converted into atmospheres. And hopefully you used Dalton's law of partial pressure. You converted all those pressures in kilopascals and millimeters to atmospheres, and you came up with the number of atmospheres. Here we go, another one. Hopefully you're taking a look at PV equals nRT. We have a volume, a temperature, and a pressure. And so hopefully you solve for the number of moles, which rounded to two significant figures would have been 270. Here's another one. And so there is our answer. And I believe I've got even one more for you.